Okay, so we have to educate the speakers about this. This is the people online are hearing you through this, and
Yes.
the headset is the people in here.
Yes, exactly. Okay, we have an excellent connectivity here. That's great.
It's unfortunate. It could be possible to have also the line audio to the live feed, but
Yeah.
it could have been possible to do.
Next time we know.
Next time, yeah. Does this like automatically switch off, or
No.
do I hold this?
Yes.
Check, check. Welcome to Kubernetes Meetup. How are the levels? Well, probably I speak a little bit louder when I'm keeping the performance.
Yes.
It's good. I think we have
Good.
good levels.
Please take the seat. Okay, there's a lot of seats in the second row.
Not to mention the first one.
Yeah, the first one also, yeah, true.
The first one is too close.
Yeah, maybe.
It's like sitting kind of on you.
I should go here.
Yeah, the other microphone. That's the stream. Yes.
Thank you. Okay, welcome from my behalf to our Tampere Kubernetes and CNCF meetup. I'm one of the organizers from Tampere, Toni, and Oliver is sitting there in the camera. So thanks to Monad for having us, and thank you for coming here. We first will have a short word from Monad, then I will show something how our community and the meetups work, and then we will have the first presentation and the second one. We will have a break between those two. I think that was the plan. Okay, so please, Aki.
Okay, welcome from my behalf. Welcome to Monad. My name is Aki Haapamäki. I'm one of the founders of Monad, and I'm just going to give you a quick overview what is Monad. So, as every functional programmer knows, that Monad is just a monad in the category of end-functors. However, the Monad, where are you now, is a software company that focuses on software development and service design, UX design, everything involved in the field of getting digital solutions to our customers. So we usually work with products that that have very long life cycle, which means that we have to pay attention to quality and long lastivity, sustainability of our deliveries. As it says, kestävää ohjelmistokehitystä. So we empathize software craftsmanship in our daily work, which means that we have strong desire for high quality solutions. We communicate transparently and openly with all parties. We engage in continuous development and education for our employees and also customers and all levels. We share knowledge and mentor, and we take professional pride in our work and in the quality that we deliver. We also take responsibility and honest with our employees and customers. And our clients are in the field, in the diverse range of sectors, in industrial manufacturing, healthcare, air traffic management, and heavy industrial machinery. We've been operating now 6.5 years with around 35 employees now, maybe. I'm not so sure anymore. 35, I think. Last year our turnover was a little bit over 3.1 million. We are committed to maintaining steady growth while continuing to prioritize the well-being of our people and satisfaction of our customers. But without further ado, if you're interested to know more about Monad and our company, please come to talk with me or with Santeri or some other people over there. Let's have a nice meetup, and soon I'm going to change my cap to my DevOps cap, and I'm going to come back here. So.
You have a good hikes as well with your company, right? You go hiking some Lapland and so on.
Yeah.
Seen some good pictures.
Oh, you mean the pictures?
Yeah.
Oh, yeah.
Maybe it's just pictures they don't hide.
Yeah.
Yeah.
Okay, thanks. So, thanks to Morat once again. So it's my turn. I will first say, what is CNCF? I believe quite many of you already know, but there are also quite many newcomers to our meetup, so welcome. So a few words about the CNCF, then about our community, and then some news of the upcoming meetups. So CNCF, it's a foundation. It's under like a Linux foundation. It's founded to host. Basically, I think it started with the Kubernetes was donated to open source. The CNCF was founded to like host the project. But nowadays it's also much more than Kubernetes. So there's a lot of text, and while you read it, I could maybe ask that how many of you don't know what Kubernetes is? Yeah, I guess the answer none, because Kubernetes is basically nowadays one of the major platforms. So either you're a developer or you are an operational platform people, you basically need to know Kubernetes. That's one of the like key technologies, but CNCF is also much more. So CNCF, quick about the structure. So there is the actual CNCF, the governing board and so on. I mean they are working as a paid employees. Then there are the technical oversight committees. There are like technical architects from different companies. They like basically govern the projects. And then there's the end user community, where also there's a lot of big companies. But then about the projects, so they follow this model, graduated or sandbox incubating graduated projects, just to maybe raise the interest. So there's more than Kubernetes. What could I highlight? I don't know, most of those are at least quite familiar to me. Then there are also some more names sandbox. Then what CNCF also does is the certification part. So there are the basic Kubernetes certificates, Kubernetes developer certificate, security certificate, so on. And now in KubeCon they announced that if you pass all of them, then was it Kubernote, you get a hoodie or something, so, if you want to. Then if you are actually a service provider like hosting Kubernetes or something, you can like achieve something like that. Then the community part, okay, CNCF itself, it's like hosting for example, KubeCon. The last one in Europe was not that long ago. Some of us were there, like me and Oliver, so if you have interested, you could discuss with us. And there's also in Helsinki, was this KubeCon Reloaded, so that was quite nice meetup. You can watch the YouTube video. There were like recap of some of the findings, and actually 2 of those presentations were also held in the meetup. Oh, sorry, in the KubeCon, so they had a recap at the meetup. CNCF, it hosts a lot of events. For example, this is like an official CNCF meetup event. And then to us, there is a cloud native Nordics community, meaning that in Nordics there are a lot of communities. You can see Tampere, Turku, Helsinki, then not all, but many Nordics major cities have their own meetup groups, and all of these we try to collaborate. And now in Finland we have something like almost 2,000 meetup members in our Kubernetes Finland group, that is basically Helsinki and the others, and then in our Tampere group we are already near to 400. So thank you for joining here, and if you want to know more, you can go, there's the hashtag, but I was about to show the next one because I was about to promote the Slack. So there is this Cloud Native Nordic Slack. I don't personally like Slack that much because it's like siloing the communities, but anyways, that one is quite nice. So there is almost 1,000 members already, and there are like whenever a KubeCon comes or events, there is some activity there, and also some discussion, but not that much, meaning too much. And we are always looking for speakers and also the organizations hosting the events. So that's ping me or Oliver if you want to speak. It doesn't need to be too much. So the upcoming events, Helsinki, June 6, soon more about that. It's something different. And then in Tampere we are planning the August, there's no like date yet. But this June 6th, it's a Kubernetes 10 years birthday. So they're announcing, is it tomorrow something? There is about to be some kind of celebration. Is it in Helsinki? I don't know that much. I just found that from the internet and I know that there is something upcoming. Maybe we know more tomorrow? Or do you, Oliver, know more?
No.
At least not what we can say. Okay. But that's all. If no questions, I think we can go on and start with the first presentation.
Okay, I'm gonna put my DevOps hat on now. So.
Cool one.
Oops. Presenter vie jossain jemmassa. Noniin. Kuuluu. Joo. So, our presentation is about Pulumi and how to manage Kubernetes resources with Pulumi. My name is, as I already earlier said, is Haapamäki, and here is also co-host Tuomas Peltola. And as I said earlier, that we are honest. That's why there's two of us, because we didn't have so much time. I said that I will do the slides, you will do the demonstrations, so that's it. So, bear with me. So, Kubernetes-as-Pulumi. What is Pulumi? Pulumi is a modern infrastructure as code tool that allows developers and infrastructure teams to define and manage their IT resources using familiar programming languages. It supports well-known languages like TypeScript, JavaScript, Python, Go, anything with .NET like C#, Visual Basic, F#, and Java. And if it supports Java, doesn't it support Kotlin?
Yeah.
So, and of course, when you can use real programming languages, you can use real programming language constructs like utilize loops, functions, classes, and other standard programming features to create modular, dynamic, and reusable infrastructure code. And other key features of Pulumi, so that it's basically cloud agnostic, sort of that you can write code that can be deployed across different cloud providers. Like you can deploy to AWS, also Google, Azure, and there are over 100 different providers to different platforms. But of course, we are concentrating on the Kubernetes side. And one of the key features of Pulumi is also like the state and concurrency management. State is basically infrastructure metadata, which Pulumi uses to determine what needs to be created, updated, or deleted. And these features, the state management also includes like previewing the configuration, checkpointing it, concurrent logging, deployment history, and encrypting secrets, for example. So basically, the Pulumi tries to streamline the process of managing cloud resources and make it simple as writing code in your favorite IDE. So, how does Pulumi then work? So, this picture shows a little bit the key components of Pulumi project. In Pulumi, you write a program, and in the program you describe how your cloud infrastructure should be composed. To declare new infrastructure in your program, you allocate resource object whose properties correspond to the desired state of your infrastructure. These properties can also be used between resources, as seen inputs, outputs between the resources, to handle any dependencies. And programs reside in a project which is basically a directory containing the source code and some metadata how to run the program. And after you write your program, you just go to the command line, run the Pulumi command, Pulumi up from within your project directory, and this command creates an isolated and configurable instance of your program known as stack. And you can see stacks on the right side. Basically, these stacks are similar to different deployment environments that you can use when testing and rolling out application updates. For instance, you can have like development, quality assurance, or production stacks. Oops, too fast. Well, how do we then define these resources? Well, here is very simple example how to define a deployment for Kubernetes with TypeScript. Soon Tuomas is going to show a little bit more complex example, but basically this is very simple that we just import Pulumi Kubernetes library, and then we create a new deployment object which has name Nginx. Give it specs, selectors, one replica, and template, container information. And when you put this to your index.ts and run the Pulumi up, then you should have basically, you can preview the Kubernetes deployment YAML created from this. So, how does the Pulumi work under the hood? Well, it looks something like this. Pulumi functions similarly to Kubernetes, that it utilizes a desired state model, configuration model. You define desired state of your infrastructure through code, specifying what resources should exist and how they should be configured. Pulumi's deployment engine then compares this desired state with the current actual state of the infrastructure deployed in the cloud. If any deviations are detected, Pulumi automatically reconciles the differences by making the necessary adjustments through the API calls to the Kubernetes API. And you, or any other cloud provider as the, as the picture shows. These pictures are straight from the Pulumi website. So, And because Pulumi supports different different languages, it needs some sort of mechanism for abstracting the specifics of the language environment. So then there is this language host. And the language host runs the code that you've written and registers the infrastructure resources defined within the code with the deployment engine. And basically the deployment engine keeps its own state in this that they call a backend. Basically the backend is just JSON file that can be a local file, and or it can be cloud storage, some S3 bucket, or you can use default Pulumi cloud. And yeah, that's about it. Introduction side now, this time.
Yes. So, here we have a brief example of using Pulumi with TypeScript. So, let's check this out. We basically have a TypeScript, and then we have two Pulumi libraries, Pulumi itself and Kubernetes support. So then let's start here. As you saw in that example, you create these resources. You give them a name, and then very familiar. This is exactly one-to-one with what you have in those Kubernetes YAML, but in TypeScript. But you can use also Helm, and here I, for example, have this cloud native PC that is deployed with Helm, and not anything more about that. As you can see, the values are not really typed. There can be anything. That's not that great. Everything else you can see here that you get type information here, and very good information what you want, what this is supposed to be. More namespaces. Then we have something different here. As you can see, this is not exactly standard Kubernetes resource. So this is custom resource from that cloud native Postgres. And Pulumi has this tool CRD to Pulumi, which can generate this code for you. So you get the types here, and you can use this TypeScript typed, and not just give it some manifest that it will create. So, and this also has this information from that API specification here in these properties here. So you get information straight to your IDE.
What languages does it support? Only TypeScript, like if you Java or anything else?
Yes, I think it was supported for all platforms. yes, that was that. So then I have created this OWASP dependency track installation with the deployment. First I tried to do that as a Helm chart, but the Helm chart in question was a bit questionable, and the way it wanted to the environment in wasn't really an option here, so I created my own instead. It's pretty standard stuff here as well, but you can see that we have this. We can create these variables here and use them in multiple places. No need to copy paste everything. Here you can see an example of that turning those outputs into inputs. So this is kind of unnecessary here, but because we know the name, what the name is, but for an example. So we get the name from that database cluster, and then we happen to know that the cluster specification says that it will create this secret that will append this app to it. So this is typed as output. So we get the output and we give it to here as an input. Yeah, and then we want to, of course, create service for it, but that is pretty standard stuff. So I have created here as an example how you can do how you can create a service for any deployment if it if you want to expose all the ports from the first container. You could do it a bit different if you want, but this is a very basic example of that. So we give it a name, and this deployment that we have created, we create a new service. We take all the information from that deployment, and then we drill down through a couple of specs to find the containers, to find the container ports, and then we apply this local function here. So this takes a list of container ports and it returns a list of service ports. So if these follow the same model, you can use this for any deployment you have that you want to create service for it. So I have deployed this already, but let's make some small changes so we can preview what the Pulumi shows us. Let's do here as well. So let's first preview, and here because this uses this actually encrypts your state, you need to have this passphrase. In my case, I don't have any secrets here, so I have only empty passphrase here. Now it tries to figure out what it do. It takes a bit long this time. Very long. Yeah, now we have it. So you get this diff that tells exactly what has changed for your resources. If you are happy with it, you can do Pulumi up. it tries to do that again. There's an option, quite new option, where you can save the output from the preview as a plan and then use that as well. There were some issues with that. I think it doesn't cover everything, but we haven't used it yet, so no idea how good it is. So here it's also brief overview what it will do, and then you can check the details to see the diff again. We are happy with it, and we will run it. So the status what it is doing, and then when it's done, it will return. And yeah, that's that. I will show one thing from this what we have here in the beginning. So we have these types here. Then we have this Pulumi configuration, and we are reading this main config from it. What we have here is we have this local here. This is one of those stacks. So in this case we have for this local deployment, and here we have this. This is namespaced, this configuration, so we can give configurations for these libraries that we have in use. In this case, Kubernetes, that we tell that it should use this context, so we are not actually accidentally doing anything for production or anything else. But other than that, we have have our own configurations here, some resource use configuration for our database and for the API server. And so we have this type defined here, that we will want these resources and how we use them. Yeah, there we just take the database volume to the size here, and this was a little bit more interesting. Where was it? There. Yes. So we are just giving to this resource property this everything that is here in the API, and if we check what is there, we see that it is API config, it has requests and limits, and then we have these resources where we have any key and then string. This is not great in our case, but the way that is typed here requires this. But here you can see that this is this type checks and works, even though we have this totally unrelated type here, and this is the power of this structural typing that is in TypeScript, that we can do things like this, that we can have our own types, and when they happen to be structurally similar to what is in the Kubernetes, we can just give them there and it will work. Yeah. Any questions about this example? All right.
Does it only check against the state, or does it actually check against those states deployed in front?
By default, the state,
Can you repeat the question?
Yes. So the question was, does it check against the state or the actual deployed resources? And Answer is that by default it is state, but you can give a flag that will refresh it from the actual resources, and after that it will check against that state. Yeah.
Do you do bare metal deployments with Pulumi?
Sorry?
Do you do bare metal deployments, like provisioning of bare metal through Pulumi?
No, that's not in our setup.
Mm-hmm.
We are only doing these Kubernetes resources.
I guess you could provision VMs as well.
Probably.
There are a lot of these resource plugins, so there might be.
How does it compare with solutions that are already existing, like for example the HashiCorp, Packer, and Terraform, which nearly do exactly?
Yes. I guess we will answer that briefly. But if you have any questions about the example, I can. So yeah.
How does it handle the API version changes? So does it, realize that if your cluster, if you're trying to deploy something which has a already outdated version of certain object, how that's handled?
Yes. Okay, the questions about API versions, and you can see the version is here. We haven't yet encountered anything with it, so we don't really know anything more than that. These are typed here with the version. So I guess it wouldn't work if that's not yet that is not anymore supported by the Kubernetes version, but I don't know.
So kind of that if you make your own structs about this, like for instance for a resource, well that's not changing. But let's say you make your own struct in the language that is selected.
Yes.
It's kind of like basically you kind of hardcode the API like version.
Yeah, but if that changes, you will get the type check error here that this doesn't work if those are not compatible anymore.
When you update the versions of like let's say APIs that you already you had a dependency on Kubernetes NPM package, I guess.
Yeah.
If you update the version and there is some deprecation of specific word, like for example Helm v3, v2, is there any sort of state move common type of stuff that it migrates between the old version to new version, or any state management kind of stuff? The code, or you need to run some
Yeah, there are state management, but we haven't yet had any reason to deal with those, so I don't know more
so
about
you don't
those.
know, is it possible from the code or not? So
Yeah, no, don't know. Yeah. Okay.
So, a couple of slides still about the pros and cons. So to be said, we've been using this now 4 months, so we don't have yet encountered these all kinds of fancy version changes yet. So we'll probably know more in 1 year. We can keep another presentation then and say that this is crap. But now I think there are more pros than cons. So in my opinion, it's easy to learn. There are good getting started documentation, like oops, you you just go to the pulumi.com docs and then get started. Select your cloud provider, let's select Kubernetes, get started. It tells you what the getting started is, and then there's installation for different environments, how to create the project. It has this very simple wizard. You can just write the base YAML by hand if you want. It's not very complex. And then there's the same example. Run Pulumi up, blah blah blah. So it's very easy to get like started to test it out. And then there is this thing called Pulumi AI, which can help you in many cases. It's chat GPT, of course, with some turbo and with some Pulumi steroids. But for example, make me a static website with Nginx container to Kubernetes. Web page should say hello Pulumi. Let's see what it does.
Every time different.
But yeah, hopefully writes it there. And let's go to the second pro. I myself, in the heart, I'm a programmer, so this is real programming. It's way more fun than configuring YAML files. So, so you can create reusable components, functions, and of course TypeScript and object-oriented. You can create classes and such. So that's nice. Let's check if we already have some AI answers. Yes, we have namespace, we have config map, which contains hello Pulumi.
Could you zoom in a little?
Oh, yeah, sorry. So we have namespace, then we have config map, which contains the index HTML and hello Pulumi, and then we have deployment, metadata containing the namespace, replicas template. It at least looks fine to me, but of course you have to try it out. But I don't have now my system set up so that I would, but at least it looks fine. But I'm gonna come to soon back to the Pulumi AI on the other side of the pros. So, and another pro is that the typings are just great in everything. And with the CRD to Pulumi, you can create typings to custom resources. So, and sharing the state between collaborators through backend, that works nicely, and secrets are encrypted. So, if for some reason your JSON file that basically is the state, somebody gets hold of that, it doesn't worry so much because the secrets are encrypted. And the Pulumi Cloud works great. It's basically, it's free for one user. It looks something like this. You can see all the activities when you've run the Pulumi up, changes, and so on. But of course you can just store the stuff to whatever cloud storage. Then of course you don't have all this all this fancy UI that the Pulumi Cloud provides. But then to the cons, finding real-world examples. I'm gonna show you when Googling stuff. Pulumi Postgres operator to Kubernetes. Okay, you get a lot of answers, but all go to the Pulumi AI pages, which might work or might not work. So that's how useful AI is sometimes. So this is a little bit, when you have some specific problems and you want answers to it, it's very hard to find answer. Well, it's very easy to find answer, but not correct answers.
Is it when you save on your documentation, use AI?
What?
Generate some documentation for you?
Yeah.
If you want to
And you also get a lot of, well, I'm not 100%, but you also get a lot of like answers that, yeah, like this. So that's not very nice. But yeah. So you have to figure out stuff quite a lot by yourself, just by Googling the real YAM examples and then how do I do this with TypeScript. And one of the cons are that Tuomas already showed that the Helm chart values are not typed. Well, this is the problem with the YAMLs, but it would be nice if those would be typed also. And of course, with programming languages, you can make very complex structures that are not easy to understand, or you might understand it, but no one else does. So that's also a con, in my opinion. And of course, updating some resources that are defined immutable might cause you some pain. Yeah, that's the thing with any other thing with Kubernetes though. But yeah, these are currently the cons that we've found out during these 4 months. So, but that's it. Any questions?
Can you still do YAML files or Helm charts and whatever with Pulumi, or is it something like you need to translate forcibly to?
The question that was that can you use YAML? Yes, you can, because there is also like as also the AI knows some YAML, so you can still use YAML. But we've been trying to write everything with TypeScript.
Does it give you like the same preview if you just use YAML with the preview?
We haven't used that feature.
But I guess so.
I think so.
Yeah.
So if you want to run it on some CI/CD, I guess you would like to, not on your machine. What's the dependencies you need to have? Like, for example, dependency on node version. A specific version of Pulumi comes with like dependent on node. What's because it's one layer on top of it. So what do you need?
Yeah, we haven't had any problems with. There have been some Pulumi updates, but not yet problems with those. Of course, we can install it to some container with apt-get or whatever the Pulumi and.
So does it install npm like the node version for you, or you need to like
you have to separately install Pulumi and then node version.
Yeah,
whatever language you are using?
Yeah,
Yes,
language.
exactly.
Is there any sort of dependency between which Pulumi requires which node version or whatever other?
Yes, I think there was some compatibility matrix.
Another question, do you, like in your case, use only one state file, everything is just like saved in one state? Or do you like have any like, you know?
We have two at the moment. Okay. Not very much, but not just one.
Okay.
Yeah, the answer was that do we use multiple states? We have been using just two, and the other one is very simple.
Can you interconnect those two in TypeScript also, like use the output from the other?
Yes,
and the input to the other?
it's possible, but we haven't been doing that yet. But it's possible. Yeah.
Related to the CI/CD part, how would it, I mean, I know how this works in Terraform, and GitLab has a integration with Terraform, so it can manage the state internally. So kind of, if you have a state somewhere, I mean, like your repository has the state, do you commit it as a file? I mean, where would you need to store the state if you're working with your repository, so that you can actually then, for instance, deploy?
The state is stored. It's in the picture. The state is stored to the backend, which can be like S3 bucket, or it can be the Pulumi cloud backend. So
You don't store it in Git, no.
Right.
Regardless, is it encrypted or not, I guess you don't store it there.
So does Pulumi put it in S3 for you, or do you need to do that?
Yeah, it does put it there.
I mean, you need to provide, I guess, some authentication.
Yes,
Yeah.
yes,
Instrument
that's
it
it.
to be able to connect, but yeah, it will manage it.
the Pulumi cloud itself works just like it pops up your browser window and you log in, and it works very seamlessly with that.
Like one thing regarding, just as a question, if you do only so do you have the Kubernetes installed already? You are just doing the deployments using Pulumi to it, so you don't manage the infra itself with Pulumi. Yes.
Yeah.
Okay.
Have you had any issues like with the? I really like the fact that it types the CRDs as well, but I think some CRDs might be finicky and loosely typed, or some badly typed interfaces. Have you faced any issues with like badly typed custom resources?
Yes, there was some problems. For example, using the CRD to Pulumi with the Postgres operator, there was some properties that were generated to the typings file were just like a kebab case, and they weren't. They of course don't work straight away if you don't have. Yeah, so basically you get some sort of compilation error when you try to put Pulumi up against those, but you of course get compilation error that where it happens, and basically in this case it was just fixing a couple of lines from that typings file that CRD to Pulumi created. But yeah, it doesn't work out of the box.
But
always.
you can fix the issues like with that the Pulumi to CRD to Pulumi created. You can fix them yourself too. We store the typings that we create. We store them to the version control, so that we are not like. It doesn't create them dynamically. Yeah.
Maybe it could with some script, but it's better this way.
And another question: can you just use Pulumi like a Helm to just generate templates of the Kubernetes YAMLs? Like, could you just create one big YAML with Pulumi and then use some other tool like Argo CD or something like that to actually manage the state of the cluster?
I think it's possible.
Yeah, it's possible. I looked into that as one option. Yeah. It works.
Because in my opinion, like YAML is like Kubernetes YAMLs and stuff. They are really nicely typed, but the editor support, like the IDE support, is sometimes like really horrible. Like, just try to find JSON schemas for some CRDs yourself and get them actually working on your editor. Like, it's not like one 10-minute job. It might require hours or days. sometimes, if you even happen to find the right schema for it. But I really like the fact that it types them automatically and it works in the editor.
But yeah, what I also, when doing this presentation, I googled up that some people that have been using some other than TypeScript, that probably the TypeScript is the first-class citizen sort of, so it's probably best to use TypeScript with Pulumi. I don't know how well it works with the .NET or with the Java.
One difference between at least native providers for like Kubernetes or Helm for between Terraform and Pulumi, I can say you could see the difference in the YAML what's changing, while in Terraform if you do deployment it just shows you have old YAML, you have new YAML, no comparison what's gonna change, you just okay apply, let's like wait, like hope for the best.
It's
like,
just deleted everything.
yeah,
Well, you mentioned that how did you end up in Pulumi? You didn't answer that yet. But if you
We have
compare
tried
CDK,
everything else, and
if
they
you
were
compare, for
disappointing.
example, CDK and how did you?
I know you guys have used CDK-TF, like how does Pulumi compare?
Well, we haven't used CDK.
Oh no, not you
CDK,
guys, but another team.
Yeah. I think it was down to CRD support that it wasn't really that good in there, if I remember correctly.
Yeah.
Yeah, thank you.
Thank you. Yeah, it was now time for the break.
Was not anymore.
It is, yes.
Virittelemään, kun mulla on vähän ollut vaikeuksia jossain.
warm up, so it's the main session of the evening, I guess. Just a joke. So yeah, thanks for having me here. I went to KubeCon Paris just a couple of months ago, and I met Oliver at the hallway track, and I agreed that I could come back to the CNCF and Kubernetes meetup to give a talk about confidential containers. I've been visiting these events, these meetups, a few times in the past. I've been talking about what Intel is doing in the cloud native space and Kubernetes space, more on the hardware accelerator side of things. And exactly 2 years ago, it was April 2022, when I was talking specifically about confidential computing. And today's session is more about like a recap, or some of you might still be new to confidential computing, so I have a short recap of what confidential computing is about. But then my main focus my main focus today is specifically about the CNCF confidential containers project that I've been working, I guess, for the past 2 years now, and I'm one of the maintainers in the project today. So yeah, so I work for Intel. I've been working for Intel, I guess, a bit longer than Kubernetes has existed, 10 plus years. But I started with embedded Linux type of things, and I've been working in cloud native space for the past 5 years. 5 years now, I guess. I started at Intel actually in the very same building. So this building was the first office that we were located, but we now have a small office in Hervanta, and then we have my cloud native colleagues. We have another office in Espoo, Wested, where most of my Finnish colleagues work. Okay, so I basically pretty much covered what I'm going to be talking about today. So a bit of confidential computing terminology recap. This is, I guess, a bit new area to many, because we don't have the confidential computing capabilities being offered in CSP environments today. We are getting there, but we are also still quite early stages in getting the confidential computing being adopted on a larger scale. And then after the quick terminology recap, I'm going to give like examples how confidential computing can be taken into the Kubernetes environment. So I have a few examples of how different confidential computing environments can be used with Kubernetes. And then the main topic is about the CNCF confidential containers project deep dive. So that's what I'm going to be spending most of my time, I guess. And then demo, of course, I have an Nginx demo coming as well. So when we talk about the confidential computing and what it actually means, so that the classical example is that the confidential computing brings the third pillar into the overall data security. So we have had data in transit security with TLS and IPsec for quite long time, and we have had data at rest security with file system and hard drive encryption for quite a long time. But what we haven't had, and like I said, basically adopted too much at all, is encryption when the data is in use. And what that means that it is in use, it's basically when the CPU is processing the data for example, in the data center environment. So without any confidential computing capabilities, your data, when executing on a cloud vendor virtual machine, the cloud vendor can basically get to see what you're processing in their environment. And yeah, indeed, so confidential computing brings the third pillar, that it protects the data also while it's in use, and this is very beneficial and useful capability when you are processing data that should not leak in some untrusted environments, for example, public clouds. And the key pillar, or the what enables this confidential computing is the trusted execution environment. So this is basically a CPU level capability that CPU offers a mechanism to build environments that are provide full data confidentiality, integrity, and code integrity. And what this means is that you can basically make sure that when you are executing data in a trusted execution environment, anyone outside the trusted execution environment won't get to tamper with the data, won't get to change the code that it's executing. And one thing that on my slide it says that trusted execution environments may include features like attestability, but many say that there is no confidential computing without this attestation capability. And what that means is that as a remote user of some trusted execution environment, for example, a confidential virtual machine, you can basically run a verification process to make sure that the trusted execution environment is exactly running on a genuine vendor-provided CPU, and it runs the code bit by bit exactly how you expect it to run. And what is also important for the confidential computing is the concept of trusted compute base. So it's the wide term for this is that it's basically a system that is critical to your environment security. So any bug inside your trusted compute base may break the security of your application. And the common thinking is that the smaller your TCP is, the likelihood that you run into some bugs gets smaller. So that's why the goal is that design for small TCP to make sure that what you have inside your trusted compute base remains kind of more secure, or it likely remains more secure. Examples of trusted compute base sizes and how this kind of works in real world. So I have like three examples here. So without any confidential computing, your whole platform is basically your trusted compute base. So including the hardware platform, the BIOS, the cloud vendors, host operating system, the hypervisor, and then of course the guest operating system, meaning all the VMs that your CSP runs for you. So they are all part of the same TCP. So any breakage in, let's say, a vulnerability in the CSP's host operating system or a hypervisor can basically also break what you are running in the CSP environment. That's like always the possibility. Then going to the other extreme, you have capabilities, trusted execution environment capabilities, such as this Intel software guard extension, that you can build very small size TCPs. Even I get this example that your virtual machine is protected, but with SGX you can build like a library level or even like a function level trusted execution environments. And then this is like the other extreme of building very small size TEEs. But what I'm going to be focusing on today, and which is what we use with the CNCF confidential containers project, is the VM level isolation. So basically the CPU provides you the isolation at the virtual machine level. So your guest operating system, of course the virtual machine administrator, and then all the applications that you run within the virtual machine belong to the same trusted execution environment. So the TCP size is basically your virtual machine. But what is considered to be outside the TCP is then everything that the CSP uses to run your VM. So even the hypervisor that the CSP uses to spawn your VMs, they won't get to see what is being processed inside the virtual machine. So this basically builds a wall, or gives the protection that your virtual machine, and you don't trust the CSP, and the trusted execution environment basically guarantees that the CSP won't get to see what is inside your VM. We have lots of different vendors, so it's not just like what you can find from Intel CPUs. We have what is called as the trusted domain extensions, but AMD, IBM, they have their own similar technologies, so they basically pretty much provide the same feature set and capabilities for like memory encryption, CPU state integrity protection, and remote attestation. Those are all the key capabilities of confidential virtual machines. We have also ARM and RISC-V based technologies, but they don't exist in the market just yet, so they are still being worked on. But moving on to the Kubernetes space and how to map the trusted execution environment capabilities into what Kubernetes uses. So I have three different ways to use TEE protected or confidential virtual machine based technologies in Kubernetes. Of course, the very basic one is that you have virtual machines that could run on your own bare metal system, but they could also run on the CSP side. That the CSPs, for example, they provide you like confidential virtual machines as the Kubernetes worker nodes. Like I said, in this case, that the CSP can't see what you have in your what you have running on your confidential virtual machine based Kubernetes worker nodes, and then the CSP is considered to be outside your trust boundary. Then you can of course run like confidential VMs using projects like KubeVirt, and then my main focus today is about the Kata containers based confidential VM / sandbox mechanism, where basically your pods are wrapped in their very small sized confidential virtual machine based sandboxes. And this basically gives you the smallest possible TCP size for your Kubernetes-based deployments, because in a Kubernetes environment, your pod is basically the smallest unit of execution, or smallest unit of scheduling, basically. In this case, if you're running on a bare metal Kubernetes node, even your cluster admin can't see what you are running within a single pod, provided that the pod is being configured in a way that it won't allow things like kubectl or exec into the pod. And this is one of the features that we've been thinking how to enable smoothly with the confidential containers project. But the basic idea is that, okay, you just schedule a pod. You might get to see logs, but it also depends on how you configure the logs and things like that. But the basic idea is that, okay, everything outside the pod is considered to be outside your trusted compute base and is considered to be untrusted, pretty much. Okay, so a bit of reasoning why this confidential computing is important, and I've tried to highlight some of the cloud native specific ones. So of course AI is a huge thing nowadays, and then combined AI with the confidential computing capabilities that allows like new usages for things like if your company has a very high value AI model that it wants to protect, and it won't even trust the CSP to get the AI model being run in a cloud environment. With confidential computing, that becomes possible, because okay, at that point the CSP won't get to see your model anymore. And what you can do is you can even move your AI model fully encrypted into the cloud, and then only decrypt it inside a trusted execution environment. And that's how your high value IP is still considered to be safe. There are also new ways of using AI. One is called federated learning. I recently exposed to the idea. The basic idea is that you won't move your data into the cloud, but you always process local data. Let's say multiple hospitals collaborate together on their local data sets, be it some MRI images or things like that. They work on their own local data sets, and the inference model is being transferred to the hospital, and then before the collaboration with the federated learning starts, the basic idea is that all the different parties, they attest to each other. That basically guarantees that the code that is being processed in the trusted execution environments is not being tampered, and which also means that the local data is not leaked from one hospital to another, for example. So each collaborator, they work on their own experiment, and they report back the results back to the aggregator, and the aggregator is then responsible for updating the model, and then aggregate back the updated machine learning model to the collaborators. But the basic idea is that the updated model has the training or inference results from all the collaborators aggregated into one. But of course, other usages as well, in addition to confidential AI, is just something that I came up with, that I see work being done, is secure software supply chain. So think of your cloud-based CI/CD deployment, CI/CD environments where you're doing code building in cloud. So what you can do with confidential computing is that you can make sure that your build environment has not been tampered with, and you can avoid all kinds of software supply chain attacks with that type of model. Of course, you can also securely process your code signing keys in trusted execution environments, because they won't be leaked outside the TE. One of the use cases we have also had with CNCF confidential containers specifically is that you could also fully encrypt your container images, and in such a way that, okay, you can encrypt them, but then process them in clouds in such a way that the images won't be decrypted on the CSP side. So they are being decrypted inside the pod itself. And the decryption keys are being provisioned into the pod sandbox using the remote attestation capability, and you can the image is being securely decrypted inside the TE. I talk too long because my screensaver goes on. But so okay, so now let's get to the confidential containers deep dive. So what and why? So what are we doing here? So we got accepted into CNCF I guess two years ago roughly. So we are still at the sandbox level at CNCF, looking to get to incubation hopefully sometime in the future. But that's why we need you as the adopters of this technology, because that's also partly how the CNCF maturity steps work. So it's not just about the technology itself, but it's also about users using those CNCF projects. So still at the sandbox level, but hopefully getting to incubation at some point. So yeah, so I already kind of bit touched on this topic. So we are using, or it's basically the key dependency for the confidential containers project, that we use the hardware provided capabilities to build confidential virtual machine environments. But this is also not just like an Intel thing. We have several different hardware vendors participating in the open source project, and all of the design of confidential containers is like fully vendor agnostic. So the same software project we can use on, let's say, AMD, Intel and IBM hardware platforms. The basic idea or the goal of the project is that we kind of try to standardize the way how confidential computing is being enabled in a Kubernetes environment, and also in such a way that we try to hide some of the confidential computing specific things from the workloads themselves. So the idea, what we don't want to do is that the workloads would have to be modified, for example, to be able to take the benefits of confidential computing. That's too difficult, especially at this stage of the confidential computing adoption, where everyone is new to the technology. So this kind of provides a very smooth transition from your existing workload deployments into the confidential computing based deployments in a Kubernetes environment. A bit of architecture, a bit of technical details. This might look like complex diagram. So, but let me try to explain it. And then if I'm not able to explain it, let's take some questions afterwards. So what we have in the confidential containers project is we have some of the confidential virtual machine guest side components, and then we have components that we need for the remote attestation to work, and also what we need for the encrypted containers use case, mainly and or originally for the encrypted containers use case. So we basically need a key broker service of some sort that basically maintains or hosts all the image encryption keys, and then when the pod wants or needs to decrypt an image, it knows where to find the keys that it needs. So it always then connects to a key broker service, and between the pod and the key broker service there is a remote attestation taking place. And in this case it basically means that the key needed to decrypt the image is only being provisioned into the confidential pod if the remote attestation is successful. And the remote attestation then checks for things like, hey, okay, this runs with the correct kernel, the virtual machine root file system is what we expect it to be. But these are all like policy-based decisions. So what are all the different checks that the key broker service checks to make sure that this is a real confidential virtual machine. But it also, of course, like it's not just like software configuration, but what is really the key is that it also needs to check that the confidential VM really runs on a genuine TEE enabled platform, and each vendor, they have their own mechanisms to provide the evidence that, hey, this is really, for example, an Intel TDX system, or this is an AMD system.
So is the trusty run on the Kubernetes or is outside of it?
Trusty, yes, so good question. It is the thinking is that this trusty runs in some trusted environment, so that's not run in the CSP environment, so it's run somewhere that you basically trust. Of course, you could run some of these components in TEEs themselves as well, but the basic idea is that the trusty components are being run in some trusted environments.
Is it like something that you expect to run yourself, or there will be another provider? It
depends on your use case pretty much. We haven't thought about it too much, or we don't have too many examples like how this is being deployed. So in our very basic demos, and what you're going to be seeing soon, is that well, it's not a good example where this trustee can be deployed, but it can basically be deployed as yet another pod in your cluster. But that's what we do for demo purposes, pretty much, for simplicity.
But isn't it the idea if the trustee is also on the cloud provider side that they can simulate in a way that they are running in the TEE, like they can potentially tamper with the trustee?
Well, they can. So each VM basically, you can see that it is what you expect it to be. You can also see that if the CSP tries to lie or tries to cheat on you on that. On a previous slide, I had this diagram that the kata containers container runtime was run on a bare metal platform. So that's basically one of the default setups that we have. But we also have in our confidential containers project this idea of peer pods. And what this peer pods means is that it's not easy with the confidential computing capabilities to run virtual machines nested. So typically what you get with typically what you get with CSPs is that your Kubernetes worker node is a VM itself, and trying to run yet another VM on that VM as nested VM, as in like a confidential VM, a pod, it's not possible, or it has like severe performance degradation. What we do with peer pods is that when a pod is scheduled on a node, we use the cloud provider APIs to spawn like a peer pod, which is yet another which is yet another CSP provided VM virtual machine somewhere in the cloud infrastructure. So that's where this peer pods name comes from. But the basic idea is that, okay, it's a bit of cheating. Your pod won't be running on the same node where it got originally scheduled, but it runs on yet another confidential VM somewhere in the cloud infrastructure. And this is basically what my demonstration is about, and what is sort of nice thing about this is that also yourself, you can go to Azure, for example, and try to get my demo reproduced, and getting your first touches on confidential computing and confidential containers. So we pretty much follow the CNCF basics, like we host community, we have all our code open source under the confidential containers org. We have a CNCF Slack channel called Confidential Containers. We have some sub teams focused on things like peer pods development, so they have their own sub channels, but this is basically the main channel where the discussion takes place, and weekly calls, weekly community calls, same as with the Slack channel. So some sub teams may have their own calls, but the main community call takes place every Thursday. So welcome. But then let's get into the demo part, which I have about what the peer pods set up. So this runs on Azure, and I have an Azure Kubernetes cluster set up on Azure there. And just getting back to your question, or basically what I just said, so I have also the trusty KBS key broker service being deployed in the same demo cluster that I have here. And then the peer pods, the confidential virtual machine pods, they run on Intel TDX, and that's, I believe, public preview, and it means that you should also be able to try them out yourself if you have an Azure account. So not much to see here, pretty much, other than on the right hand side I have just like the KBS logs. So it basically shows you that there's some activity happening when the pod wants to get a secret, wants to get a key. On the left hand side, like I said, like I promised, I have an Nginx deployment here. Nothing special with that, other than other than this one little change. So Kubernetes basically, I don't know if you have you have been exposed to this runtime class name parameter. So I think we had someone in the audience who had experimented with Google's gvisor. So changing from the typical or normal runc container runtime into something different. Google, they have the gvisor. Kata containers, you can switch between kata containers and runc using this runtime class handlers, and the configuration to choose one specific runtime container runtime handler is that you specify the runtime class name in your pod specification. And in this particular setup, we have a runtime class handler configured called kata remote, which is then capable of processing these new pods using the cloud API adapters. It basically spawns a new confidential VM, and then it deploys the workload onto that confidential VM. I have it running, I have it deployed already, so this is again like a demo setup. So in a fully secure production environment, kubectl exec should not be possible, because the control plane is also considered to be untrusted. But here I am inside the confidential virtual machine environment. And then the confidential containers project provides some in-pod services, since it's basically a confidential VM itself. We have a REST API service that the workloads can use to fetch secrets from various secrets providers, and this confidential data hub basically knows where to route the requests, and in this case it basically routes the request onto the KBS that I have running. We also have capabilities so that you can deploy, you can encrypt your Kubernetes secrets, and then the container runtime or the kata agent inside the confidential VM automatically knows how to decrypt your Kubernetes secrets inside the VM, again using the key broker services to first run the remote attestation, get the key into the confidential VM, and then decrypt your Kubernetes secrets. But this also allows you to securely just create your Kubernetes secrets object, but make them encrypted, and inside the confidential VM you basically just seamlessly decrypt them, so that the workload always gets to see the decrypted data from your Kubernetes secrets. So this very basic demo is just about fetching simple key.bin resource. On the right hand side you got to see some logs. The remote attestation took place, the remote attestation was successful, and then that's how the secret with a typo got returned. Good. Yeah, so this is pretty much what I have, but now I hope I also get some questions.
Who provides those keys, like you used to decrypt them? Who does provide the keys to decrypt?
It's basically the whoever needs to store some keys that are being used by the workloads. So that's how I would say it is the workload owner in this case.
But how do you like securely provide the keys?
Well, like I said, and like the question, there was a question earlier. So the key broker service is something that you run in a trusted environment. So you basically And key broker service means that it's a broker service, so you can basically have some HSM behind it. Yeah, so you don't necessarily have to have your keys like in some key broker service daemon, but it can broker the secrets from some other place.
Like, could you demo the kubectl nodes, for example, to show like the peer pod node that you were talking about? And is the peer pod created like one node per pod, or how do you schedule actually on it? Anything if you have like multiple pods, for example?
So it's one. Right now it is one VM per pod. Yeah, yes, one node per pod. But it won't show in the get nodes, because from the Kubernetes perspective, it's not really a node. So it's a pod.
But like from
it just runs on a dedicated virtual machine.
And it just will kind of create a similar type of node, for example, that you will otherwise specify for the node pool. Like it just be like trusted with the confidential compute.
Mm-hmm.
I mean the VM size.
Yes. Yeah. So we have which I actually forgot to add. So I wanted to add here that we also have a confidential containers.io website where you can find like copy and paste step-by-step instructions how to get this demo up. And it basically explains all the node pools and VM sizes and things like that.
But in reality, this kind of hidden cost for you that you were facing.
Yeah, that's true. But then, that like I said, so it's also not the only way to use confidential containers. So you also, if you have a like on-prem data center with bare metal hardware, you get to run these confidential VMs, bare metal kata runtime. Good, yeah.
So about the hardware requirements, like how new hardware is actually needed for this? Like if we're talking about Azure, is it a very specific set of VMs that support this?
Yes, I don't recall the Azure IDs. We have had Intel TDX generally available less than a year. So Intel Xeon Xeon Gen 5 is that made TDX generally available, but we have had CSPs and also other vendors have had CSPs being offered. AMD has been available a bit longer. We now have CSPs offering Google Cloud and Azure. They are offering TDX, and then if you buy your own hardware, you get if you want to try TDX, is you need to buy the latest Gen 5 Xeons.
So do you actually see like a future that if like cloud providers upgrade the hardware, that this will be out of the box like supported confidential compute?
Hopefully so. Yeah, and then also the kind of readily built services. So Google, for example, they have their own products for confidential spaces and things like that. So they're like a data clean room type of setups that you don't need to know much about the confidential computing as such. You just get a ready built service that you can use.
So are those like usually externally audited somehow? Like why would you trust that they are actually doing what they say?
Yeah, well, that I don't know. What I have read about this confidential spaces project in particular is that they have a fairly comprehensive web page about here's the things, how it works, and here are the different trust model considerations and things like that. Good. But yeah, go and give it a try if it's possible, and then if you run into troubles, you can find people on Slack, hopefully, with the capabilities to help.
Is it like a flag in Azure, or do you have to like install some add-on on your cluster?
No, so they are just like dedicated instance types that you just add to your node pools. And CSPs, they've made all these remote attestation capabilities available, so that is also something that you don't need to have the knowledge of. I've experimented with the bare metal setups myself, and there is a bit of learning curve to get that done, but the CSP offering just works.
One more question.
Sure, yeah, that's good. Yeah, that's what I was hoping.
How does this differ from like VM-based setups? Like, if you just have to enable like this specific runtime class, and then you're like golden, you get confidential computing. But how was it like with virtual machines? I have never deployed like confidential computing virtual machine. What's the process there? Kata containers, I think Azure is the only CSP that has provided any type of Kata-based setups in their environments. I believe they are doing like nested, but without confidential computing capabilities, it's easier to do. But with confidential computing, getting things nested is a bit more complex. So the main use case for Kata in the past has been that you just run your bare metal Kubernetes cluster, and then you just run your VM pods on your bare metal cluster. So that's basically what drove the confidential containers project to actually create this peer pods setup, because that kind of was seen the most viable option to get confidential containers, confidential computing type of setups adopted. Of course, you can do things like create your own and maintain your own confidential Kubernetes clusters. There are also vendors offering for that type of setups. It basically means that you run your own Kubernetes control plane in a dedicated confidential VM, and then all your worker nodes, they are confidential VMs as well. So you basically don't trust that the CSP provided control plane, you run your own, and then the tooling provided by those vendors, they basically take care of securing your cluster. And you basically get this seamless cluster attestation or cluster measurements that you can check that, hey, okay, my cluster is what I expected it to be. But then it also means that the cluster admin is part of the trust model, so then you trust the cluster admin and everyone who is using the cluster, because they all operate on the same data that is available within the cluster.
Can you build this with full open source software? So is there any vendor specific like parts in this?
This is fully open source, so there's no proprietary bits, no. And even the TDX setup is that all of the software components that are needed to create these trust domains is also provided as open source. Of course, in order to guarantee in order to basically guarantee the the fact that okay, these are real Intel, so some of the components would have to be signed by Intel. So we have the certain bits provided as open source, but in order to use them, you have to have them signed by Intel. But what you can do is you can build certain critical components yourself and compare with the binary output that is being used to deploy your VM. But the only difference is that you don't get to sign yourself.
Does GPU graphic compute workloads works in confidential computing?
Coming. Yep, coming. So yeah, that's a good question. So that's one of the next steps with confidential computing is that you don't just encrypt the virtual machine memory, but you also get the TEE-IO, so input-output capabilities to external devices that are outside your virtual machine. So we have NVIDIA, for example, offering something in that space. It's not like really today what the standardization is driving with certain standards, but it is already possible that you can have a confidential VM talking to a confidential GPU, basically. Yeah. So it's indeed coming, but we actually don't remember if any CSPs are offering that generally available just yet, but that's what is being worked on at least.
I wouldn't say, because at least I tested the ZES solutions from AMD, and if you spin a VM that is having let's say an AMD GPU, which is the evident choice for AMD, and it turns out that, for example, the graphic driver wouldn't load properly. It would just crash the kernel. So it's I don't know if NVIDIA is doing any better in that sense, but I wouldn't expect that to be quite integrated, given the reputation that NVIDIA has in the market, or at least in the open source world nowadays, unfortunately.
Yeah. I haven't tried it myself to say if it works or not. Yeah, but so there's the short answer to your question is indeed confidential devices are the next thing that is coming with this space.
With the background that it's having for artificial intelligence is something that needs to be. The market is really eagerly demanding.
Yeah, and like I had this one of the use case examples, so confidential AI and accelerator enhanced confidential AI is also very important.
At least in Asia, November last year, they say that they have VMs with NVIDIA H100. Confidential GPU. I don't know,
it's probably the Microsoft Ignite announcement that they made. Yeah. Good. Yeah. Thank you.
Thank you. Yes, thank you. I don't know how long we are able to stay here, but this was the official part. Any info how long? I don't know.
9
Yeah,
Not really busy.
okay, not really busy, so sometime, that's good.
Yeah.
So please stay if you like. Let's have some conversation and continue the questions. At least I have something to discuss with Mikko.
Okay, that's good.
Yeah.
That's what I was hoping.
Yeah. Does anyone else have anything?